Hello biostats people, welcome to lecture 1. Hopefully you pulled up the stuff that I recommended and have downloaded RStudio and everything already, so you can kind of hopefully follow along with me here. So let's kind of get into this first document here. The first 3 lectures or so will have documentation very similar to this here, and then from about lecture 4 on, we'll have predominantly most of the material that will be in lecture will be in more of a slide presentation format. But for now, I like to give you these basically how-to guides. I recently redid this to kind of reflect RStudio because it's something we started using full-time last spring when I taught this in person. So here we go. So you can see this was an older document, and I forgot to change the date, but that's okay. So if the beginning of this is just kind of going through, downloading R either for Windows or Mac, and then RStudio after the fact. And gives you the links in here as well. These are clickable links as well, so if you've got the PDF document downloaded, you can just click on these links. Your RStudio window will look something like mine. Yours will probably have a white background. I changed mine because I like the darker appearance, and you have a lot of different options on the way your screen looks, and you can change those things. I'll show you where to do that in a moment. But when you open RStudio for the first time, you should see 3 windows. Window 1 is your global environment. It's where anytime we create something in R, like a vector of data, or and we'll talk a little bit more about what those are. If you have a data set you imported, it'll be in there. Any function maybe you've written or created will appear in there. So basically anything you create in R will appear in your global environment, showing you that you have it. So, and those things will stay in R as long as you save. When you go to quit R, if you'll save it, those things will stay in your R environment there. Okay. You don't always want everything to be saved in your environment, but it'll be there. Window 2 is where we're going to do the bulk of our work. Window 2 can change appearance if we're doing something what they call doing an R markdown documentation. We'll give a second window here, and I'm going to show you how to do that in lecture 3. But for now, it should just look like this. You should see your console, and the console is where we do the bulk of our work. So if we're going to put in a function or put in a command, it goes in the R window, and there's a little prompt that you can't see there. Over here on my screen, you see the prompt right here. The other information on here at the top, this is not something we need to have in here. All this stuff is just information when you open R, but it will tell you what R version you have and what the date it was and the name of it. Yours may be different from mine, and that will be okay if it is. I haven't updated my R in a little while because unfortunately updating R means sometimes you have to figure out a way to update your packages you have installed. But if you ever want to clear all this stuff out or clear your screen out, you can clear console with this little button up here, or you can do it's Command L on a Mac, so I assume it's like maybe Alt or Command or Control L on a PC. But you can always click this little sweeper button, and it'll clear out your console and give you a clear console. This third box over here is got several tabs across the top. It has a Files tab, which will give you your all the files on your computer anywhere you want to go. So you can actually pull files from places here. We won't probably do that much, but you can also, like for example, I've created a folder on my desktop called RStudio Spring 21. And so if I wanted to have access to that in here so I could see what's in it, I can go find it. Let's see, RStudio Spring 21 folder, and it'll show me what's in there. It has a history file from some work I've done in the past. It has my airpoll.txt and my sat.txt file folder in there. And so those things are all there. and that's what I recommend you do, is to take any data sets I have and put in those file folders so you can see them. So we'll call these data sets into R shortly. They're not fully into R, even though they're in that folder. Another way to get that in there, though, and what I recommend from the documentation here, I say it a couple places in here, but is to set what we call your working directory as this file folder. So anything you create in R, or output you have from R, or data sets you want to call in from R, that's the folder you want to be your working directory. In RStudio, you go to the Sessions button up top, and you go Set Working Directory, and you go Choose Directory. And I'm going to find that folder on my desktop and open it there. So now it's set the working directory, and it'll actually show you the command that you would do if you did it by hand. And don't worry if yours looks a little different from mine, because your folders will probably be named something different, or maybe you'll have them in a different location, or on Windows or on PCs it's often a different looking structure to this inside part right here. Okay, it's no big deal. I'll clear that out. My working directory is that, so later on I won't have to do anything. The other features here are, you've got a plots window. So when we create plots, which we'll do in lecture 2, this is where they'll appear. It'll allow, this little export feature here will allow you to save the images as, if you wanted to save them, to put them in like a Word document or somewhere else as a JPEG, or you could save the image as a PDF file, or you can copy it to clipboard and paste it as well. So that's a nifty way of getting your plots out. Although hopefully when I show you how to use the R Markdown package, you won't have to do much exporting. All that stuff will be done in R Markdown. Your packages, R works based on a lot of packages, and you'll have some in yours when you first open it up, because there's several that come with the program. You don't have to really worry about much. The ones that need to be open are already open. We will use some throughout the semester that you'll have to import or install. You can update or install packages here. This is a way easier way than having to learn the code to do it. But like, say I wanted to install something, I can click install here. I already have R Markdown in here, so it may give me an error, but I'm going to put R Markdown in there. And this is one of the packages, if you want to go ahead and download it, we'll need later. And if you click on install, it will install the Markdown package and go through a little series. When it's done, it should be in there. And if you just go over here and type search in the field over here, type R Markdown, it should appear. Now I have two versions, an older version and a newer version, so if I were going to use it, I would click on the newer version, and it uploads it for me. And here's how you call a package forth in the prompt over here, by typing library and then the package name. But RStudio's made it nice for us where we can just click on those things. And then when we need these things, I will point them out to you, because there'll be very specific uses that we need certain packages for, and we'll have to call them forth when we want to use those things. You've got a help menu over here, and I kind of go through here in the documentation a little bit. You can just type in, like, anytime you want to know what a function of a specific type is. Like, I've got matrix in there now. If I type in dnorm in there, it brings up the what they call the log normal distribution. I guess I put DL norm. I got lucky there. Dnorm in there. It'll give me the. It did it again. Dnorm. It must be stuck on DL norm. That's why. It'll give me the documentation for that function. So any kind of function or in any package that R has in it, you can get the information about the usage of it, which will give you the different function names. And don't worry, you don't need to know what all this is now. This comes as we go. For those of you who have taken a elementary stats class or a statistics class in general, where you had to use the normal CDF function, either on the TI calculator or some other way. This pnorm function right here is that exact same thing. It's a normal distribution, normal CDF function. And the qnorm is your inverse norm, so that's kind of like what those are. But this tells you what the inputs are for those things and describes down here down below what those arguments inside the parentheses that come after the function name are. So this is a very function-driven language. We won't have to write much, and if we did have to write anything, I'm probably going to give you the code for it, so that you can just copy and paste it into the R prompt window and run it, and it'll show up in your global environment. That way you don't have any issues with it. Okay. All right, and then the viewer window over here is when we use something like the R Markdown package to produce output in a nice format, which is how I got my documentation we're currently using. It sometimes will show up in this viewer window if you set it to it. I've set my default to pop up in a PDF viewer, so mine doesn't pop up over here. So this isn't always useful for everybody, but that's pretty much the RStudio over Outlook and an for the most part. The other thing we'll use here shortly is this import data set button when we want to import data. So it's kind of nice. RStudio makes it a little nicer than the old way. The way I had to learn was a little bit tougher. So let's learn a little bit about what R can do, some basic stuff. I mean, R is basically a glorified calculator, if you want to not mince words. So you can do things, simple things like 2 plus 2. Hit enter and it'll pop out the answer. You can do something like take the log of 10 and it'll give you log of 10. Now if you want to do, that's just a basic log. That's like the natural log, okay? They don't use ln in here, but log base 10 would be log 10. All right, so there's a little bit difference, little different way that this syntax works rather than other normal calculator. But you can do just about anything you want in here. For math majors, if you wanted to use it to find a modular, use it to find mods. You can do 45% 6 and it'll produce out the mod 3. So that's the remainder when you divide 45 by 6. So you can do modular arithmetic in here too. I think you can do the div in here as well. I'm blanking on how to do that. It's been a while. But anyway, you can do any of these mathematical procedures. The order of operations is very important. So R is going to do exactly what you tell it to do. So for example, we'll say you wanted to find the average between 3 numbers and divide it by something and then multiply by something else. You've got to be careful how you do it. So let's say we did 2 times 1 plus 2 plus 3 divided by 6. If we do that, the order of operations should fall through and we should just get 2. All right. If you left the parentheses off, you're going to get a much different answer. So be careful with that and use your parentheses where you need them. I'm always overly cautious with my parentheses because the order of operations can get you in trouble. Now, what's nifty about the way that the fact that you can do this is that it won't just add numbers and things together. What we're about to talk about vectors, which is sets of data. You can use these numerical operations to add or do things or manipulate your data sets as well. We'll look at that here in a minute. So, vectors and matrices. Vectors in R are just, a single variable, as we call them, single variable lists of. It's like a list of data. It'll horizontally list it as you see here. So the first thing I want to do is create the way I can create a vector in R, and one of the simplest ways is to use the C command. So notice this is the first thing I'm creating a name for. I'm calling it lowercase x. This brings up an important point. R is very specific about it's case sensitive, so you can't X, lowercase x, and capital X are considered two different things. So watch how you name variables or how you name vectors and things of that nature, because you can run into some issues if trying to call them forth if you're not careful with how you spell things out and how you capitalize them as well. So if I create this vector, boom, it's created the vector. You see it's shown up in my global environment over here, so I know it's there. But if I wanted to be sure, I type in X and it prints out exactly what's in X. The numbers 3, 4, 7, and 8. All right. Notice that it's to get that we use a C, little lowercase c, and then in the parentheses we put our list of numbers, whatever our list of numbers might be, in separated by commas. All right. Another quick way to make a quick vector of nothing but whole numbers would be to say something like y equals 1:4. We hit enter on that and we get the numbers listed 1 through 4. All right. We can one other alternative we have. There's actually many ways to make vectors in here, but this third one is one I like a lot. It comes in handy when you're trying to create graphs, or create a huge sequence of numbers. But you use the seq command, seq, and in parentheses, you're going to type in 3. Let's type in 3, 10, 0.25. So what that's doing when I do that, the first entry is my lowest value in the sequence. The second number is my highest number in the sequence, and then it's going to go to it by 0.25. All right, these going to count up from 3 by 0.25. So when we do that, we get 3, then 3.25, 3.50, 3.75, so forth and so on. So we're just adding 0.25 each time. But it gives us a nice list of numbers. So that's another way we can create a vector. We can call certain items out of those vectors too. So if we just wanted to call out, say, the first the contents or the numbers in the 5th through the 10th position, we can do that. We type in Z. Now we use square brackets when we want to call something out of a vector, and we can just put 5 through 10, and it'll spit out the numbers that are in the 5th through the 10th position. You can do the same thing. If you push the up arrow on your keyboard, it will call back something, and you can go in and manipulate it. So that's kind of nice. Hit enter again, and we get the third element in there is 3.5. So you can call a single element or a series of elements in that format. Let's clear that screen out so we can get back to the top a little bit. It'll keep going down. You don't have to clear the screen out. We can also add two vectors together as long as they're the same length. If you're ever not sure how long a vector is, you can use, this isn't in the documentation, but you can use the length command. And you say, what's the length of my X vector I created? Hit enter and it'll tell you it's got 4 items in it. So that's a nifty tool when you're not sure like how many items are in a data set, especially if you've downloaded a data set. You may not always know what's in it. And so, or how many values are in that data set, so you might have to figure out that way. But we can add the two vectors together as long as the same length. So notice over here, both X and Y have 4 items in it. So I can take two vectors, add them together. Oop. Or I can subtract them. Or I can multiply them. You get the picture. Or I can even divide them. Alright, so we can do a lot of different things within R in that format. So I'm just kind of running through the series here. You can take the square root of a complete data set by using the square root function. Alright, so square root of Z. Will give me all the square roots for all the values in that vector. And you can square things, or you can even get crazy and do something like this. I won't do this for you, but it's kind of nice. It produces some nice numbers, oddly enough. I probably planned that and forgot how I did that. It's been a while. Also, we can create vectors of character strings for like giving variable names in a data set, or just if we want words as data values, we can do that as well, or as data values, we can do that as well. And we can do that something like this, where we go names equals, and we can use that C command again. And notice it's got quotes around it. That's how you know it's a character string. With computers, sometimes that can be a nuisance because they'll treat numbers sometimes as characters as well. So if you ever have a list of numbers pop out and it's got quotes around it, it's treating it like characters, like letters. So you won't be able to do a lot with those kind of vectors if that happened, but that doesn't happen very often. And when we need to change something like that, I'll make sure you know how to do that. But notice that when I wrote the code up here and entered it in, it has double quotes around each word. It's no different if you have double quotes versus single quotes. R doesn't differentiate between the two. So if I go back in here and make the Sue a single quote, it won't treat it any differently, and it'll give us the same thing. And if I call back names and bring it forth, it still says Sue in double quotes. So it doesn't differentiate. The one thing you do want to notice about it, and you may have to look a little close at the screen here, or at your screen, notice the quotes, but single and double ones are both very vertical. They're very straight up and down. If they're ever slanted, because sometimes if you copy and paste from a PDF file, sometimes they'll slant on you. If you have a code that won't, if you copy and paste from one of my PDF files that I give you in the future, and it gives you an error message when you run it, that means that the first culprit usually is those quotes aren't right. In other words, it copied over and gave you a different syntax for those quotes, where the R in most coding program languages like the straight up and down quotes, and sometimes with PDF documents, they'll as much as you try not to, they'll make the quotes be like slightly slanted enough, like you would in a Word document, and so it doesn't like that. So just be wary of that. That's the first culprit in a lot of issues I've seen from people have. It's usually that. Okay. Yeah, and so in the future, I'm gonna have you download data sets using code, and those codes will have single or double quotes in them. If you ever copy and paste those from the PDF document I give you into R, sometimes it will give you an error message. Double check those quotes first. I'm going to do this instead of giving you the file and having you upload the file to your computer and then do all the stuff. It'll just automatically import it into R for you, which is kind of nice. So hopefully we won't run into too many issues with that. All right. So anyway, back to vectors. Kind of got sidetracked there for a minute. I apologize. You can combine vectors together using what we call the cbind command. All right, that stands for column bind. There's also one called a row bind. The vectors don't have to necessarily be of the same length, but it helps if they are. Usually you want them to be, and so we can do call it capital X this time to give it a different name, and we'll call it cbind. We'll call x comma y lowercase x comma y. And if we put X, it will have a capital X. You'll see there that it gave me the X vector in the first column and the Y vector in the second column. Clear that out. And if you row binded them, call it capital Y, R bind, X comma Y, capital Y, and it row binded. It gave me X is row 1 and Y is row 2. So there's several ways you can build what we're going to call a data structure or a data frame, and this is kind of how you can do it using binding techniques. You don't always have to use cbind and rbind to do such a thing. There are other methods, but these are the ones that are the basic ones. Matrices. I'm going over matrices not because we'll use them much this semester, We will use them when we get into categorical data a little bit, and you'll need to use them then. But I'll show you guys how to use them when we get to that point. But I want to kind of go over them in a quick overview of them real quick for the math major specifically. You can build any kind of matrix you want. I'm going to build a matrix called A. And we're going to make it filled with nothing but zeros. That's the first entry. Is usually, if you have a data set, you can put that in as your first entry. Comma 2 is the rows, and 4 are the columns. Yep. And if you hit enter, it'll give you, and type in A and then hit enter, it will show you that you have a matrix made of a bunch of zeros. Not very exciting, but something you can do. You can also create them out of vectors that you currently already have created. So we can take our matrix, our vector X, and create a matrix out of it, a 2x2 one as a matter of fact. So we call forth Z equals matrix parentheses, and then we'll do X comma 2 comma 2. That's a 2x2. Since it's 4, that'll put 2 in the first row, 2 in the second row, and we hit enter, type in Z, boom. If you notice, let's go back over here and find the X vector here, which is right here. It has 3, 4, 7, and 8. So this did it by columns. It did 3, 4, and then it went to the second column, did 7 and 8 when it made its matrix. You can have that changed in here if you want to. And if you're not sure what the command for it is, if you type help or go over to the help menu and type in matrix, but this is another way to do it, help matrix, and hit enter over in there. It gives you the matrix command right here, along with its information. So the data goes in first, the number of rows, the number of columns, and you've got this command in there called by row equals false. So that's why it initially put ours in columns. It's because this is set to false already. So if you set that in there to be, you call that back forth, push up the up arrow 3 times to get back to that if you're following along, and then comma, and then put a by row equals capital T. Sometimes you have to spell out the word true, and sometimes you can use the capital T and it knows it, and hit enter and then type in Z. It'll give us, now you see that it's a little different than the first one. It put the 3 and 4 in the first row and the 7 and 8 in the second row. So that's kind of sometimes an important feature. You want these things aligned certain ways for certain things. I'm gonna call back forth the original one we had real quick because I wanted to match up what I have in my documentation. Say I wanted to call the first column out of the matrix. Notice in this matrix the way it's built, specifically the headers of the matrix and the rows of the column of the row headers. It's got 1 comma 2 comma for the rows, and it's comma 1 comma 2 for the columns. So if you ever wanted to call out a specific element from a matrix for some reason, some people will like to do this. It's very similar to how we did with the vectors earlier. You do Z bracket, square bracket, and then you do, if you say we wanted to call out the first column of the Z matrix, the 3, 4, we could do Z comma 1, and it gives us that. We could have done the first, the second row, 2, and then comma, so that's the row, and it gives us that second row right here. Okay. So with all these data frames, you can call things out using the square bracket features, and there's a lot of different ins and outs, and it can get kind of difficult to do sometimes to pull things out. And you can kind of get fancy with this stuff the more you learn it. You can pull out a single element too from the matrix if you typed in Z and then you put in the row and the column value. So say 1 comma 1. It'll give me the 3 that was in that 1, 1 position. So if we look back at vector Z itself, we go to 1, 1, we see that there's a 3 there. Okay. If you were in a regression class, you would want to multiply matrices and do some other operations to matrices, and you could do that in R as well. So let's say I wanted to multiply my X matrix times my Z matrix. If I do X percent star percent and then Z, I can multiply the two matrices together. And for those of you familiar with linear algebra, which I think most of you math majors should be at this point, if you look at X and Z, X was a 4 by 2 matrix, and the Z matrix is a 2 by 2, so we end up with a 4 by 2 in the end for our multiply together matrix. A couple other matrix operations. I won't delve on this too far, but that you would need in a class. If you wanted to find the transpose of a matrix, you'd use just a lowercase t is the command for that, and then the matrix name in parentheses. And if you'll notice what that does, so we've got my matrix Z up here. If I plug that in, what did it do? When a transpose matrix just basically shifts the first column and makes it the first row. So the first column here became the first row here, the 3, 4, and the 7 and 8, and the second column in the regular Z became the second row, 7, 8 here in the transposed matrix. And if you wanted to find the inverse of a matrix, you'd use the command solve and put the matrix name in there, and it will give you the transpose of that matrix. These are important if you're doing regression analysis and you're learning the basics of how it works behind the scenes. And for those of you who might take an operations research course later on, this is another nifty way to manipulate matrices, because sometimes you have to multiply the original matrix by its inverse and then add the transpose, and it kind of gets convoluted, but you can do it here in R if you want to. Okay, so let's talk about the bread and butter. So we're building up. We've made vectors and matrices, and a data frame really is kind of a fancy version of a matrix, but looks like a data set. And we can create one of those things using we can build one from scratch using vectors and then combining them together the way we've seen previously. But we're going to do something a little different here because there's a data.frame command in R. So we're going to build this data set here that I have that has store names, or store region names, store regions I guess really, and then daily intakes from each one of those stores. And so we're going to build these vectors first. So I'm going to just grab all this and copy and paste it in, since it seems like it's working fine today. And we plug all that in at one time and hit enter, and it runs it all, and we have it over there in our global environment. Now to create the data frame, we're going to give it a name. We're going to call it net, so store net basically. And it's going to be data.frame. It's the command name, open parenthesis, and then you put the vectors in the order that you want them to be in your data frame. So I want my store vector to come first, comma, then I want my day 1, comma, my day 2, and then my day 3 to be in there. And if I hit enter, and now if I type in net, I get a nice little data frame. All right. So I'm going to have you guys do this in the first project with a table that I give you. I'm going to have you try to recreate it. But we can add, the nice thing about this is if we wanted to add to this, we can add to it as well. So let's add another column to this, and then I'll talk about being able to pull stuff out of it too. But it works the same way as what we've seen with vectors and matrices, are very similar to the matrix operation actually, if you want to pull certain items from a data set or a data frame. So let's create something called daily average. I want the daily average, and I want a column of that to be added to my net data frame that I've built. So if I go and create daily AVG. Double check your spelling before you move on. And I'm going to use a new command called round. It's because I want my values in this thing to be rounded to 2 decimal places. I'm going to open up a parentheses. The first entry in the round command will be the computation we want to be made, or a data set if you have something already built, a vector already built with these values in it. And so we're just going to build the function right inside. So I'm going to create another parentheses, and I'm going to go day 1. We're going to do a simple arithmetic mean, day 2 plus day 3. All that needs to be divided by 3 because it's 3 days. All right, and then comma, that's our function. And then the number of decimal places we want to round to needs to come after it. So I'm going to put a 2 here and hit enter. And now I want to add that to that data frame we see above it. So I'm going to call net again, but I'm going to redefine net by doing net equals, and I'm going to use the cbind command, open parentheses, and I'm going to type in net, the original net data frame I had, and I'm going to do comma, then daily average. So just like before, we're keeping the net as it was, and we're adding daily average onto the end of it. And now my net looks like this. So very easy to do. You might have to think through the process and what the correct way to go about it is, but usually building your vectors and then putting them in as bounded by columns. You can also do them by rows if you have all the information at your disposal first. You could made a row that looked like this and then a row that looked like this, and put them together by rows as well. I don't recommend doing that with data.frame. Keep those as vectors here, and get them to and then data frame will automatically column bind for the most part. All right. Yeah, I was going to say real quick, if you wanted to call a certain thing out of that data frame, you can call net, and just like we did with the matrices, when we wanted to call a specific item out of the data set, we can use the square bracket. And since we don't have the numbers here, let's say we wanted a specific row, like say row 1, and then we do 1 with a comma after it because we only want the first row, and we hit enter, and it gives us the first row. We could also easily pull out a specific data value. Say we wanted the day 2 value from Cochrane, so we wanted this 2000 to pop out for some weird reason. That's going to be in. So store is the first column, so that's column 1, 2, 3. So we want column 3, but we want row 2. So we want 2 here, 3 here, and it should spit out 2000. So again, you can pull things out of R rather easily, or out of a data set rather easily using R. Let's talk about reading and writing data. I'm just going to show you how to do this section. We've already set the working directory to my folder I wanted, but that's not really always necessary with RStudio. But I want to import both the SAT data set and what we call the air poll data set. So this is how we do it. All right, this will kind of give you, the documentation will give you an overview. And the old way to do it would be using this code right here. It's called a function in R called read.csv, and the first entry is the file name you're pulling in. So the data file I have in my folder is called sat.txt. The separator is separated by commas, so when you look at the data set, it would be separated by commas, and header equals true. Now we're going to get the same kind of output here by not typing this in per se, okay? But that's what this thing is doing. And so to get that SAT data set in here, I'm going to go up here. Let's clear out the screen. I'm going to import data set from text base, and it's taken me automatically to, because I set my working directory as my file, it took me directly to the file folder I wanted, which is nice, so I don't have to search around. But if not, then you could find it over here or wherever, however your directory is set up, you can find your file that way. Click on that and open it, and it should open another dialog box. Notice it gives us the name. It shows you how the file looks already, so you can look through that. Notice there's commas separating the names above and the names from the numbers here across the way. Encoding is automatic. You can leave that. You want the heading to be yes, because if you click on no, it changes the variable names to v1 through v5. So we want the variable names, so we click yes. It's already diagnosed that the separator is a comma, which is good. It doesn't always do that immediately, but if the data frame down here looks the way you want it to look and it's separated nicely like this, then we can just click on import, and it does it imports it. Notice it's using the read.csv file. Now it does this little weird less than sign and a minus symbol here to form an arrow. This is the way the true coders say we do this instead of equals to put this into the variable name. You can just use equals. It's not a big deal. And then it shows where it pulled it from, in the file name, and then anything else, and then said view SAT, and it gave us the data set up here. So it's viewable here. You don't have to keep it up here if you don't want. It's in there, but you can also, anytime, if you close it out, anytime you want it again, you can click on the SAT in the global environment, and it'll open it up again, so you can view it that way. In the past, I've had to have people had to show this using a quick SAT, and we don't want to see the full document, but maybe the first certain number of rows. The same thing we did with the vectors and matrices to pull rows and columns out. We can do that here as well. SAT, let's say we want 1 through 5, comma, so this is the first 5 rows. It will give those first 5 rows. All right, so let's quickly import the other type of data set I put in there. Go text from base. Now I'm going to pull in this airpoll.txt file, and it should open up our box. Now notice, before you go crazy here, I like to have these be shorter names, so I just call this one air. I'm going to take the poll part out of it. It's not got the header set. It's got it set at no, so I'm going to set it to yes, because I don't want the V1, V2 through V7 down there. I want the actual names of the variables across the top. These are spaced by white space, so there's just be given a little bit of white space. Some files are white spaced, some of them are what they call tab delimited, and some are comma delimited. You won't have to keep up with that much in this course, but it's nice to know that you can pick these different choices to do that. So if I were to pick, for example, comma, all of a sudden it would automatically put everything together because there's no commas in there. So white space is the way to go. It looks like I want it. I import it. Boom, it's in there. And now I can work with that data set. More on how to do that later when we start doing some things with the variables in the data set. As a matter of fact, I'll show you later today what you do. We have to attach the data set to be able to call forth any of the variable names that are in the data set easily. But I'll show you in a minute, just here in a few minutes, how to do that. Something I'm not going to go through showing you how to do today. I think I've got it in here. But I want to kind of go over through in the document for you. When you're giving me stuff later on for R projects and you're turning stuff into me, and I'm going to require that you give me the R syntax. I'm hopefully going to be able to get you to where you can show me in very much the same format as this document you're seeing here is in, where your R stuff comes out like this, and then your output will come below it, very much like you've seen throughout the document. So earlier when I ran the daily average thing and then updated my net data set, and it spit this out. This is how the R code will be when we use our markdown, and this is how the output would be. Okay, this is how our table would end up being. So the problem with any computer like programming packages is when you copy and paste tables from it, it doesn't always come out nice. So I ran this code here, and you don't have to know any of this stuff means yet. But I ran what they call an ANOVA analysis on our day 1, day 2, day 3 daily intakes. Okay. And that ANOVA table spits out something that looks like this right here. This looks a little bit messy, and the spacing is weird all over it. It's not quite nicely spaced out. So if you were just to copy and paste the table that R spit out, the R table will actually look kind of nice. So if I were to take this and copy and paste it, let's try it out anyway. It looks nice, pretty nicely spaced out. But if I copy and paste this to a Word document or something, it doesn't always space out that way. Now, it will in a text file, but it won't in a Word file. And a lot of times you guys want to work in Word files, especially those of you who aren't familiar with LaTeX. This won't transpose over very well. And this is the result. So this is an image that I got when I took it to Word. If you can do something called syncing the output, I'm just gonna talk about this. I'm not gonna do it. But syncing, you create a file name for what they call your sync. All right, sync using the sync command here, and then you print that summary that we got to get this table up here, and then end the sync by doing the sync without anything in the brackets, and that says to end it, and it will write a file out into your folder. That will essentially have that table in it alone, and then you can open that. It'll save it as a text document, which you can open in Word and then manipulate it around. You still have to manipulate it around. I'm going to hopefully keep you from having to do that. But if you have to do it, then the setting here when you open in R, it's going to ask how do you want the program to read the file. I choose other encoding and then select the Unicode UTF-8 option that comes up in Word. And then once imported, it will look like this. It'll look a lot nicer. It'll look like it does in R. So it'll import it the way it's supposed to look. I'm hopefully going to keep you guys from having to do that this semester, though. So we'll talk about that more in Lecture 3 and hopefully getting nice output. Okay. R also has a series of built-in data sets, which from time to time we may use for certain things. If you're ever not sure what data sets R has at its disposal, or if you just want to play around in R, you can type in data, and it will bring up the list of data sets right there for you. But if you hit data without anything in the parentheses and hit enter, it brings up the first one automatically. I don't want it to do that. It will bring up a prompt up here which tells you the data sets and what those data sets pertain to, so you can pull from them. I'm going to pull one out of here real quick called the trees data set. It does not need to be in quotations, but if you pull data trees, it'll open up data trees over here, and it doesn't show anything right now. All right, but it's in there. We do trees and then square brackets, and we just want to look at the first 7 items. It's been actually it's not in there. Why is it not in there? Let's see. Define columns. Oh, I forgot to put a comma in there. I'll always leave mistakes I'm making here on the run because I want you guys to see that it's easy to do, and also it's not a big deal. So in this data set we have girth, height, and volume. There's obviously more data in there than just that, but that's what's in there. If we tried to call forth one of these variable names at the top here, we're going to get an error message. There's a reason for that. If I just say girth, it says object girth not found. And you're probably like, why? Well, if you look through your environment, you probably don't have anything called girth over there. And you won't. There's 2 ways to call like if you just want a column of data to work with out of a data set like this, you can call the trees. You can use the trees command again, use the money symbol in between it, and then put the variable name afterwards. And then when you type that trees money girth, it will give us that. The The one problem with that is that if you have to do that, you get sometimes some lengthy names. You don't always want to do that. My preferred method is I like to attach the data set to the workspace. This is one of those weird things that R does, but if you use the attach command, open parentheses, and then put in the data set trees, it will attach it to our data frame. And now it says more information. So if I click on trees, it's attached and it shows all this information up here. Whereas before it said promise next to it. All right, now we know we have 31 observations. Close that out. And so now if I type in any of those variable names, I can get, now girth shows up. And it's in there, and I can use it, and I can find the mean or the standard deviation, or manipulate that data any way I want, or use it for something I want to use it for. Okay. When you're done using a data set, you're gonna, and you know, like in a project, you might have to use other data sets. You might not want to have them always attached. So a quick way to do that is detach. The detach command, and you can list any data sets you want in there. So I'm going to just type in trees, and we're going to detach trees real quick by hitting enter. It's detached, which means now if I try to call forth girth, it's not going to be there. Notice it didn't show up, and it gives me an error again. But if I want to totally remove that data set so I don't have any weird error messages pop up, and the reason let me clarify this real quick. The reason an error message may show up is because you have too many variables with similar names in different data sets, and they'll kind of sometimes get confused with one another. So you may want to remove that data set before working with another one. It doesn't always cause an error, but occasionally you will get one. But remove trees, and you'll notice trees should disappear after I hit enter from up here, and it does. Now it's out of there. I don't have to worry about it. Let's kind of wrap this up because I want to go over some data, the data types that we'll use. This last stuff is just pure out information. We're going to use RStudio throughout the semester for different things, and I'm eventually going to show you how to use some packages called R Markdown and knitr. So if you want to practice downloading those packages, remember you can go to packages, install, and R Markdown I did earlier, so maybe you did along with me, but knitr is another one you want to have, and install that. Updating loaded packages. I don't need to update. Mine's already in there, so cancel. I'm going to cancel mine. Want to restart R prior to installing? No. Can I cancel it? I want to cancel this. Yeah, I want to cancel it. Since I already have it downloaded, it's giving me that error message. But for you, it shouldn't. You should just install it immediately. But those are two packages we'll need by lecture 3 that you can download. And what I hope to do is, and while I don't have this mastered here, I do have it mastered how to create a PDF file and Word file from RStudio, because that's what we're looking at here. But getting nice tables out is not always easy. How R usually put our net table earlier. I rebuilt our net table here, and how R usually puts out that table is looks like this. And this is completely fine for me for your turning in purposes, by the way. All right, I don't expect anybody to do anything more than this. All right, I'm perfectly fine with your stuff looking like this. But knitr, along with something called Cable Extra, will allow you to make nice looking tables for like purposes of if you're writing an article for a publication or something like that, you may want a really nice looking table. You can make a simple nice looking table here. This particular code really only works if you're knitting to a PDF or if you're in a LaTeX style. Don't worry if you don't know what LaTeX is. I'm gonna give you a workaround so that you can not have to necessarily, you can use LaTeX without really knowing how to use LaTeX. Here's a very fancier version of the first table. Same thing. Neither one of these will show up in a Word document if I knit it. If I do what we call knit the document to a Word file. But this last one will. This last one will actually knit to a Word document. So if you take these things out. So Word documents are a little bit problematic when knitting. So I'm going to hopefully have it where everybody in here can knit to a PDF. And we'll figure that out as we go throughout the semester. Okay. So one other thing I wanted to talk about here, I just want to go through real quickly, is the data types that we'll experience throughout the semester. This is should be rehashed from elementary stats and whatnot. But we'll have qualitative data or quantitative data. So qualitative data is categorical. And it breaks down into two different types of qualitative data. You've got nominal, which is data that can be categorized and has no natural ordering to it, like state of residence, or gender, or religion. None of those things have a natural ordering to them. They can be forced to be ordered, but they're not natural. And then we have ordinal data, which can be naturally ordered, and those are things like soft drink size, or maybe t-shirt sizes or dress sizes, things like that. Anything that has a natural ordering to them, because we think of one thing being smaller or larger or better than, or in somehow we can put it in a natural ordering, like from best to worst or smallest to largest, things like that. Quantitative data is numerical, and we'll work primarily with quantitative data this semester, except for when we get into categorical data stuff for a little bit. But these can be broken down into either discrete or continuous. Discrete data is usually represented by whole numbers. These are usually just countable values, like number of students in a class, number of animals you observed at a feeding spot in the wood, in the specific spot in the woods or something. Anything that's like that you can count as whole numbers is considered a discrete value. Continuous data is something that can take on any value in an interval. Now, I'd like to think about this. Continuous data are usually measurements, things such as height, weight, distance. Anything that can be measured is continuous, because we usually take those values when we make measurements, and we're really, like, nobody's really 5'8". If 20 different people measured that same person with the same measuring device, they might not all get the exact same height, especially if that measuring device was very detailed, right, or very precise. So continuous variables typically be things that we end up rounding off because our brains can't wrap around how to deal with numbers like that, and so they're not countable either. But continuous, some textbooks like to break the continuous variable down into two additional things, or two additional scales: the interval scale and what they call the ratio scale. The interval scale, which you see I've got a little note down there on, is the interval scale has a 0 point in which is arbitrary. And body temp is a perfect example of that, because body temperature, depending on whether you measure it in degrees Celsius or Fahrenheit, can have very different meanings. Absolute zero is different for each type of temperature scale, and even if we throw in other temperature scales like Kelvin or something like that, those values all have different meanings, so therefore they're considered interval scale variables. Ratio scale, the 0 point is fixed. Blood pressure is a good example of that, because there's only really one way we measure blood pressure. So if something is where the 0 point's well defined, or it means it's very meaningful, or always means the same thing, then it's a ratio scale. And that's pretty much it for the data types. Next lecture we'll go over how to get descriptive stats, and we'll go over a little bit about those as we go through the document together, and we'll learn how to get them out in R. and as well as some how to get graphs in R. So we'll get going on that next lecture. So welcome to the class, everybody, and good luck to you, and we'll talk to you later. Bye.